What we're doing today is testing how we can allow inspections to be done remotely so that we don't need to have experts. They're not trained for safety and for whatever is required to be on the field, that are able to visualize what is happening on the wind turbine blades, to visualize the degradation, to identify failures.
It's really important to do regular inspections at rotor blades at windmills at sea. Often that really small damages due by lightning or rain occurs on the rotor blades.
Having inspection done by drones like the one we have here that allow to stream the data to remote experts allows to reduce the number of personnel on site.
When you have drones, you can do it much quicker and much easier, and it's not that expensive, you know. So we have to find a way to do drone inspection from a big distance on a regular base, but then you need a good connectivity with the drones. At sea you don't have 4G, for example, so we have to invest in connectivity to do the good observation with drones.
5G as a standard comes with dedicated functions that support drone-based applications requiring high reliability, low latency and throughput. The use case that we did today wouldn't be possible in previous generations of cellular networks. What's more, the Unmanned Valley is the perfect place to test drone-based use case, and together with Wind Transition Department of TNO, we came up with a perfect use case, which is the wind turbine blade inspection.
This project from TNO, working with a 5G network, well, that's the future in our opinion. So then you can send a drone whenever you want, and you get the best pictures from a long distance, and you have the connectivity with the drone, so it will return to base. That's important as well, of course.